Welcome to Algebra 1, Chapter 7, Section 4, Division Properties of Exponents. Our review vocabulary is quotient. Circle the expressions that show the quotient. Quotient means division, so these two show a quotient. The quotient of two negative integers is always positive. The quotient of two positive integers is always positive. When you have the quotient of a negative integer and a positive integer, it will always be negative. Our vocabulary for this section is property. In mathematics, a property is a feature of a number, a set of numbers, an operation, or an equation. So looking at number 5, let's draw a line from the equation in column A to the property it illustrates in column B. In column A, we have the quantity of x times y times z. That's equal to x times the quantity, y times z. Since your values are being regrouped, that is the associative property. The second one, x to the 12th raised to the 3rd, is x to the 36. That is the property of raising a power to a power. And the last one, x plus 0 equals x. That's the identity property of addition. Let's look at an example of each property. Here we have the associative property. See that the numbers are in the same order, but they're being regrouped by parentheses. In the next one, we have the distributive property. As you can see, the A is being distributed to each of the items inside the parenthesis. In the commutative property of addition, that tells us you can change the order. And you can remember that by CO, change order. You can change the order of the items being added. This property also works for multiplication. And the last property is the identity property. The identity property states that any number times 1 is going to equal that number. When dividing exponents that have like bases, you simply subtract the exponent parts. So it becomes a 3 minus 2, because they're both a's, which of course equals a to the 1st, which equals a. Here are 2 problems for you to try. Go ahead and try them, and then check back here for the answer. The first one is x to the 4th divided by x to the 3. So it's x to the 4th minus 3, which equals x. The first part, which equals x. The second one is a little trickier because there's a negative 2 here. So this is z 5 minus a negative 2, which of course is z 5 plus 2. Those become a positive, which is z to the 3rd power. How'd you do? In words, to divide powers with the same base, you simply subtract the exponents. Here's the algebraic example. You see we're subtracting the exponents when we divide them. And there are 3 examples for you. Now, even when the exponents are fractions, you follow the same rule. So when dividing exponents with the same base, you subtract the exponents. Just like in any other fractional problem, if they are fractions, you need to find a common denominator before you can subtract. So if we're going to simplify y to the 3/4 divided by y to the 1/2, we're going to have y to the 3/4 minus 1/2. So we have to find a common denominator of 3/4 and 1/2. Well, that would be 3/4 minus 1/2 is 2/4. 1/4. When dividing numbers in scientific notation, the first thing you need to do is read the problem. So go ahead and read the problem. So when determining the density of Honduras that year, we're going to take the population and divide by the area. We will then separate the powers of 10 from the other factors. So you're going to get 7.33 divided by 4.33. And of course, we're going to take the 10 to the 6th divided by 10 to the 4th. So it'll be 6 minus 4. Go ahead and simplify the exponents, which is 10 to the 2. And then we'll divide, keeping our 10 to the 2, round to the nearest thousand, and then rewrite the problem in standard notation. Moving on to raising a quotient to a power. To raise a quotient to the power, raise both the numerator and the denominator to the power, then simplify. So looking at 14, we're going to raise both the numerator to the fourth power and the denominator to the fourth power, and then we'll simplify. Same as when you have a fraction as an exponent. The 9 will be raised to the 1/2, and the 16th will be raised to the 1/2. And again, we'll simplify. Let's look at 2 ways to raise a quotient to a power when the problem is a bit more difficult. So remember, when raising a quotient to a power, to raise both the numerator and the denominator to that power. So on the problem marked 17, you can see we have a quotient, and it's being raised to the fourth power. Using this method, we're going to raise both the numerator and then the denominator to the fourth power. So we have a to the 3/4 to the fourth. So we're going to multiply those out because a power raised to a power, you multiply. As you can see, we worked through the problem. And notice we did the same with the bottom. A to the 5th to the 4th, multiply them, get a to the 20th, and then we'll work through the rest of the problem. Now let's try a slightly different approach. In this approach, we're going to work what's inside the parentheses first. So we're going to take a to the 3/4 minus 5, obviously get a common denominator. After we subtract them, we're going to take that quotient and raise that to the fourth power. Of course, multiply them and get your answer. Now, in this box, write which way you think you prefer. And of course, you're welcome to change your mind later as you get more practice. Pause the video, write T for true or F for false, then restart the videos and see how you did. Let's take a look at how you did. For the first one, this is for number 20. Is that a true or false statement? It is false. You would apply 4 to both of these, which equal 1 to the 4th and 7 to the 4th. For 21, going across, this would be true. Remember, this negative here would make this 7 to the 3 over 2/3, which of course is 7 times 1 over 2 cubed. Then use the commutative property to get and simplification to get that. For 22, again, this is true. This would, to make that a positive, you would make this 2 over 7 squared, which would be 4 over 7 squared. So that is true. It would also equal 4 over 49. And for the last one, that is false because this negative did not make the reciprocal of what was inside the parentheses. Just in case you're having some issues with this still, let's take a look at this a little bit slower and remember exactly what that negative exponent does. This negative means we're going to do the reciprocal. So we're going to do the reciprocal of the numerator and the reciprocal of the denominator. So this is going to be 1 over a to the nth power. And right now our b is in the denominator, so it's going to move to the numerator and become b to the nth power over 1. So our final answer here will be b to the nth power, when we multiply straight across, over a to the nth power. So in short, what's happening is this negative symbol is flipping what's inside the parentheses. So working this problem, you would flip what's inside the parentheses, use the reciprocal of it. And the negative exponent would become a positive. And then you'd go ahead and simplify this out. This 2, that's the exponent, applies to everything inside. So it's 5 squared, b squared over a squared. To simplify further, you have 25, that's the a squared, or 5 squared, that's the 5 squared, b squared, a squared, and that would be your simplified version. This is our last slide that we'll do together. There's just more examples here. Let's take a look at these. Feel free to skip this part and go do this in the lesson check if you want to, or set with me if you just need a bit more practice. So using this example, the first one we could do 2 different ways. We could simplify what's inside first and then raise it to the third power, or we could raise the third power to everything inside. I kind of like to simplify what's inside, so that's what we're going to do. So in the numerator, we have a squared plus 1 because this is a 1 right here, over a cubed. All of that's still cubed. So we have a to the third power over a to the third power raised to the third. Well, what's anything divided by itself? Well, of course, it's 1. So a to the 3 minus 3 would become a to the 0. So a to the 0 raised to the third power would become 1 raised to the third power, which is 1. On the next example, again, I'm going to simplify inside first. So I'm going to take my x's and I'm going to divide them out, which is subtracting them. So I'm going to have 2x1 minus 2 to the negative 2. This becomes 2 to the x negative 1 raised to the negative 2. Now I'm going to choose to apply this negative 2 to everything inside. So I'm going to get 2 to the negative 2, x to the negative 1 times negative 2. Well, negative 1 times negative 2 is going to become a positive 2. Remembering that this moves it to the denominator and squares it. So this is going to be x squared over 2 squared, which is x squared over 4. Let me move this up a bit and we'll do the next problem. Again, I'm going to simplify inside first. So I'm going to make this m to the negative 1 plus 15 over m squared to the negative 2. So this becomes m to the 14th over m squared to the negative 2. Now, this is subtraction. The 1. So that equals m to the 12th to the negative 2. Of course, a power raised to a power, you multiply. So it's m to the negative 24, but that's a negative exponent, so it's not simplified yet. So I'm going to use a reciprocal, and that's m to the 24th. Work through the lesson check. If there's any questions, make sure you check in with me tomorrow.